Hey AP friends, do you remember how to take the derivative of just an exponential function? These were pretty easy, right? If you just have the f of x equals e to the x, well, f prime just gives you back out e to the x. That's pretty nice. And now that we're applying chain to it, if you want to find the derivative of an exponential using chain, we always said that the exponent is always going to be your inner function. So if I say, what is g prime? First, let's rewrite g as e to the u. So therefore, g prime will be basically just e to the u. But because of chain, we're going to multiply by the derivative of u on the outside. Okay, so that's just plugging back in. We just get e to the u was 2x. And the derivative of u up here is just 2. And we can put that constant in the front. Now that's great. E to the functions, e to the x, is always an easy one to find the derivative of. But not all exponentials have e as the base, right? What if you walk down the road and you see these, where now the base is actually 2, or the base is 3? That's not e to the x. That's different, but we do have a really cool handy formula that's going to help us out. Okay, ready? This one's going to be memorized, so this would be another great flashcard. Here it comes. Basically, the derivative of any exponential, any exponential. On the left-hand side, the derivative of e to the x is just e to the x. Great. Where the d dx just means the derivative. And in fact, when you start adding chain to it, the derivative of e to the u, where u is your inner function, is, again, just the e to the u, but you have to include u prime, or the derivative of u multiplied on the outside. Okay, so that's if your base is u. But what if your base is an a, like a 2 or a 5 or a 10? Well, look at this formula and let's memorize, friends. The derivative of an exponential where the base is not e, well, look how actually similar it is. I take the derivative of a to the x, and look what's the first thing that pops out, an a to the x. That happens over here with e to the x too, right? So that's great. But when the base is not e, we have to include this little piece at the end. So the derivative of a to the x is, again, a to the x, but multiplied by the natural log of the base a. Okay, again, the derivative of a to the x is a to the x again, but multiplied by the natural log of the base. And just like before, if you have chain here, let u be your inner function. That's always the exponent. So the derivative would be, again, a to the u pops out again with ln of a. That's all the formula. That's the new formula we just learned. But chain says, hey, you have to multiply by the derivative of u on the outside, or du dx. Okay, so the one thing we have to add is just this little piece on the right-hand side. You have to include ln of a. That's multiplied by your a to the x. So let's go back to those friends. Here we go. So here your a is 2. So f prime, the derivative of this, would be, again, a to the x pops out again, so I get 2 to the x. But I need to multiply by the natural log of the base, which here is 2. And there's no chain here because the exponent is just x. So this would be your derivative, 2 to the x times the ln of 2. The ln of 2 is something we'd probably have to put in the calculator, or on the non-calc section, we just leave it as is and walk away. Is it okay to write it as ln of 2 times 2 to the x? Yeah, that's fine too, because ln of 2 is just a constant number, so it's okay to put in the front. But there's no way of combining these two terms. We have to keep them multiplied and separate. Okay, how about over here? Now, look, we do have a chain because we have an inner function, so we can let u equals 2x. There we go. So g of x is basically just 3 to the u, where my base here is 3. All right, g prime. G prime would be, again, 3 to the u, but we have to multiply by the natural log of our base. And then, because we're in chain, we have to multiply by the derivative of u. So again, this part is just from the formula. This part is the addition because of chain rule. All right, let's clean it up. Here we go. The derivative should be 3 to the, remember what u was? Times the ln of 3 times the derivative of u, the derivative of 2x is just 2. And there you go. Again, we can clean it up if you want. We can put maybe the 2 ln of 3, since that's just a number, in the front. and keep this exponential part in the back. And that works too. So that's how you take the derivative of an exponential when we have our new formula. Now, why does this work really quick before you run away? Why does this work? Let's see. Let's pretend you're trying to find the derivative of a dx, but you're secretly turning a into e. So I am taking the derivative of e to the x. But you know the derivative of e to the x is going to be e to the x. But why? Can we use our new formula? Ready? The derivative of e to the x using our new formula would be, ready? E to the x pops out times the natural log of, what's the base? E. And there's no chain, so we can leave it. Now, do you remember your log properties? Do you remember what the ln of e is? Remember, ln is a base of e, so the ln of e just turns into 1. And 1 times e to the x is just e to the x. So that's why the derivative of e to the x just gives you e to the x, even just using our new formula. Okay, folks, so let's put these into our flashcards so we have these memorized and good to go for the rest of calculus class. Good job. Have a wonderful day.